Good day, everyone. So, my topic is illustrating standard error. Standard error is the key of the statistical measure to use qualify the amount of variability or uncertainty into the sample mean estimate. It provides insight into how much the sample mean, the average of the sample data deviate from the true population mean. Illustrating standard error can help better understand its importance to inferential statistics, particularly in hypothesis testing and confidence interval. What is standard error? The standard error is defined as the standard deviation of sampling distribution of the sample mean. It indicates how much the sample mean you calculate from random sample is expected to differ from the true population mean. The formula for the standard error of the mean is standard error equal to standard deviation of population over square root of sample size. The larger sample size, the small standard error, meaning the sample mean is likely to be closer to the true population mean. Why is standard error is important? Standard error is crucial for several reasons. Estimating population parameters. It helps estimate how much the sample mean is likely to deviate from the population mean. Confidence interval. The standard error is used to calculate confidence interval, which provide a range of plausible values for the population mean. Hypothesis testing. Standard error is essential in calculating the test statistic in many statistical tests, such as t-test and g-test, which rely on comparing the observed sample mean to the hypothesized population mean. Illustrating standard error. To illustrate standard error effectively, we can simulate or graph the distribution of sample mean from multiple random samples. This can show how standard error behave with the different sample size and standard deviation. Simulating standard error with a normal distribution. Consider a population with a known mean equal 50. A standard deviation is equal to 10. We can draw random sample of size and calculate their sample mean. As the sample increase, the standard error decrease. Graphical illustration of sample distribution. A visual demonstration can further illustrate standard error. In a histogram, we can show the distribution of sample mean from multiple random samples of the sample size. As the sample size increases, the histogram becomes narrower, illustrating that the variability of sample mean decreased. Sample size. The distribution of sample mean is wider, indicating higher standard error. Larger sample size. The distribution of sample mean is narrower, showing reduced standard error, confidence interval, and standard error. A key application of standard error is in constructing confidence interval, where G is the Z-score corresponding to the desired confidence level. As the standard error decreases, with a larger sample size, the confidence interval becomes narrower, indicating a more precise estimate of the population mean. In conclusion, illustrating standard error is vital in understanding how sample mean behave and how we can make inference about the population. By visualizing how the standard error changes with sample size and demonstrating its role in confidence interval and hypothesis testing, we can gain a better understanding of the reliability and precision of sample estimate. Whether simulation or graphical presentation, standard error remains a cornerstone of inferential statistics. And that's all. Thank you.